Good afternoon, ladies and gentlemen. It's a pleasure to be around for the 5G. Now we are talking going a step ahead 6G. What I'm trying to do in the next few minutes, maybe the next 10-15 minutes, to take you around what are the opportunities that are around 6G and what is going to be the power of 6G, these opportunities, challenges, and how it's going to impact our life. We know there's going to be a lot of discussions on the applications. The applications are all emerging. People who are talking about killer application. To put very short, 5G talked about integration and interconnection of man, machine, and object. 6G takes one step further to add the gene also. So which means you're going to go in a complete virtual environment. That's going to be the reality. So which means you're going to have a XR, VR in a real-time world. So your phones and other things is going to take a next level of change where you're going to have a complete immersive experience. The 2D calls which you are having today, the calls what we make, they're all called 2D calls. So because they're two-dimensional one, it's going to be replaced by what we call as 3D calls, the holograph communication. We are going to see all the connected robotics that's going to happen. The complete utilization itself is going to see change happening. Most interestingly, we have been talking about this brain net for quite some years now. Now the vision of this brain net is going to be a realization. So we are going to actually bring in brain net and solutions surrounding it, because 6G is going to drive towards what we had, connected devices to connecting intelligence. It's going to be a complete intelligent network which is on its own. We'll be seeing some of the slides on it. And we are going to drive, especially in the nano and the bio-nano stuffs. What we have been talking about, Internet of Things, is going to go to the next level of Internet of Nano Things. We are talking about Internet of Bio-Nano Things. That's going to be the new era. From the perspective of the customer, we are going to experience what we have, a complete metaverse environment. The way of life, what we have, is completely going to have a complete sea change in the next few years. Education sector, we are going to talk about immersive education, which means as a student, a child goes on reading, through this sensor network, I think the speakers were talking about, one of the key elements in the 6G is going to be the sensors, network sensors. We'll be able to identify what is the extent to which the child is learning, and then accordingly the teachers or the course correction happens. So that's what it's going to be a complete sea change in the education sector. Similarly on the agriculture, everywhere we are going to see we are going to talk about the real digital agriculture coming in also. As far as the telecommuting, we know because of COVID, we had a lot of issues of this video conferencing. Though we went into this video conferencing era, still the personal touch was always a problem. This is going to be solved in 6G, where we're going to have a complete telecommuting, where you'll have a holographic thing, somebody comes and sits in front, and then you start chatting, and it will be a real feel. Of course, the entire roadmap of what the network should look like has already been defined in 2020 by ITU's focus group. So that is going to be the base on which the 6G itself is going to revolve on its own. We're going to talk real intelligent cities. The word of smart is completely going to be eliminated into what we call intelligent. We're going to have intelligent cities, intelligent environment, everything is going to be intelligent, because it's going to be a real marriage of AI into the networking sphere itself. And we can keep on talking about the different applications, like as I mentioned about the brain net. So the brain-to-brain communications, when it happens, is going to really revolutionize the next Web3. Web3 is going to come in, then it's going to be a conversational image. The sensors is going to be, and human interaction is going to be at a different level, where only by gestures you'll be able to communicate to anyone, even devices, etc. And be it for your health, or it could be education, or for health, entertainment, all these purposes, brain communication is going to play a real big role. Another very, very interesting thing which is going to happen is people were talking about security, how secure is the data, everything. The concept of blockchain itself is now going to move into the network, as we can see in the figure, starting from the infrastructure, even your spectrum sharing, everything is going to be on a blockchain-based driven infrastructure. You're moving the blockchain to the edges, to the core. You're going to have an overlay network for the service sector, and we have a core network on blockchain. So the entire thing is going to be distributed ledger technology, which is going to run on as the base of the 6G. Most interestingly, what is happening in the bio is The biosphere, everything is going to what we call nano, which means we are going to have nanorobotics, which is going to go into our body, which we can feel and add the sensors. So probably you'll have your pulse oximeter nanosensor or blood pressure nanosensor, ECG nanosensor. This brings out what we call Internet of Bio things. That's another field which is coming up. And everything is going to go on a pervasive nano things. That is another key driving application that is going to drive into the 6G. The urban space itself is going to completely go into different jig. People are talking about e-commerce sites where today we go and purchase this item. This entire step is going to change what we're going to have, a digital twin space, where you'll be able to feel, look, feel, and sense the object before you buy. So maybe in your physical shopping mall or your product details or a communication with the customer, everything will go as into a complete digital sphere where you'll have a digital replica made, and the sense of touch and feel also is being inbuilt into it. That's going to be the driving application that's really going to come in. Another very, very interesting thing that's going to happen in 6G is going to be the federated learning. Morning people were talking about how my data is secure, where the data is going to be there. The concept of the machine learning, which was a big data analytic itself, is completely moving today. Today, when the concentrated amount of data, because when you do a machine learning analysis, all the data needs to come to a common place. When the data comes to a common place, the data analysis happens. How are we going to do that? That we're going to do away with what we have. Different types of machine learning is going to come, including quantum machine learning. But the key base of it is going to be federated learning. And this has been already approved. I know in your release, somebody with the latest 3GPP has already approved this for 5G itself. So this is going to be a base on which your networks is going to be built. So where you can see, if you can have a look, you can see in the edge, every device, whatever device we have, itself acts as a database. And these database, your data, the actual data is not shared. The privacy data is always stored in your device. It is anonymized, and this data will be having a small model kept at each of the device. Each device acts as a simple model, and then you will have an aggregator model, then you will have a global model. So the entire concept of machine learning itself will go for a toss, and wherein all your protection of your security, private, everything is properly in place. We have a vision in Tamil Nadu. We call it digital TN. We have already started working on it. It's a 5G, where what we think and dream is a collector, district collector in his district, you should have an intelligent display where you should be able to get data about everything in his district. For example, how much is today's my GST sales? How much fertilizer has been used in the district? What is the number of trucks moving in, moving out, temperature, weather pattern? Is there any commodity is going to happen? Using CCTVs, we can even do a predictive analysis. Any commotion is going to happen. So all this sort of a digital TN, which vision we have, this we have started building it in 5G today, which I'm sure will go on an immersive virtual way when 6G comes. For example, on the mobility side, we have the road data, vehicles data, traffic data going in. On the health side, personal data, hospital statistics. Even we can see why a particular medicine is more used in a particular area. Is there any particular disease in that particular area? Outbreak of any disease. All this could be very clearly understood. Infrastructure side, the buildings, the airports. Commerce, as I told you, even we will be able to track the amount of taxation that is happening. How much tax are you collected today? That information is available. In education side, agriculture, of course, agriculture, as you mentioned, we are going into what we have, digital agriculture. We talked about precision agriculture, etc. But we are going to put a real use of this. For example, a satellite map will be continuously monitoring a field of agriculture. If it can detect any locust or any insect, send in information to a common database. This database triggers the nearest BTS. Through some sensors, the drones will be activated. Then probably pesticides control and a photograph of the confirmation. Everything happens automatically. There's no human intervention at all. This is what the vision has been dreamt of in 6G. Of course, with these applications, what are the key driving trends? Now, as we know that we have always a spectrum problem, the spectrum reliability is going to increase, and we have to pack more number of bits together. What is going to be the technology behind it? Now, we have been talking about, I'm sure you know about aerial thing. We are going to move from aerial to volumetric, which means bits per second per hertz per square meter, which we are talking about. Now we are talking about bits per second per hertz per cubic meter. That's in volumetric. That's going to be the sea change we are going to have. And we are talking about, for this amount of application, two very essential things are very, very important. One, the speed, which people have been talking from the morning. So at least you should need a peak data speed of 1 TB. And at least the user end, it should have at least 1 GB. So that's the speed we're thinking. And most importantly, latency. In 5G, the latency should be much more better than latency. Because in 5G, if you are trying to do a remote surgery or a more autonomous driving, the amount of reactive time should be very, very, very less. It should be in millisecond or microsecond. That's not presently available in 5G. So that 6G should be in microsecond. If you talk about the C plane, it's going to be 0.1 millisecond, or it's the U plane, it's going to be at least 1 millisecond. So that is the amount of stuff we are thinking. And moreover, the mobility. The speed should be around 1,000. Number of devices that is going to connect is going to be 10 power 7. Most interesting thing is on the efficiency, energy efficiency. We'll come back to that in subsequent slides where we talk about the new concept of energy harvesting is coming. So no longer the devices, IoT devices. Just imagine you're going to have billions of devices put everywhere because it's going to be a man, machine, object, gene working together in a 6G environment. Billions and billions of devices. You can't afford latency. You can't afford speed problems. So to take care of this, and the most important is your power. So we are going into what we call battery-free environment of energy harvesting techniques for these devices. This is another new area of research that is coming up. So that is, and another thing very important is the emergence of smart environment. We are now talking about smart environment, smart surfaces. And what are these intelligent surfaces? They are nothing but RIS. They are nothing but a reflective intelligent surfaces. What happens is, today, we have a lot of antennas available everywhere. So the cell structure is designed. You have a tower in the center of a cell, and then you have the inter-cell problems, issues all available. This is completely go away in 6G. 6G is going to think about a cell-free MIMO technology where everything is everywhere. And most interestingly, every device will have a separate antenna. That's one of the research going on. So if you say n number of antennas, k number of users, n is going to be greater than k. That's the vision which we have been thinking on 6G, which means the technology, the modulation, the multiplexing pattern, everything is going to change. Of course, we are going to be the SDM, the space division multiplexing, but an advanced version of NOMA going to come in. These reflective intelligent surfaces could tune the range of frequencies, whatever is available. And the research is going on in a number of ways. They're very simple. They can be made as a paint. You can paint a building, paint a glass, or paint your surfaces, any of these surfaces, which will act itself as an antenna for your services. And they consume little amount of power. It's a research on its own. So we are talking about such smart environments, smart intelligent services coming up in a big way. All of us know that in 5G, we've been talking about SON, the self-organizing networks. Now, this SON is going for a toss. Now, we're going to talk about self-sustaining networks. So the networks itself will become intelligent. It itself will allot its required computational resources. Whatever resources allotted, intelligently allots, and the network sustains on it. Suppose there is going to be a outage in one in one of the towers, automatically the payload of the other one is increased or decreased to ensure you have a complete ubiquitous connectivity. More interestingly, what is going to happen is it's going to be a complete convergence of communication, sensing, control, localization, and computing. Localization will be up to some centimeters. And network sensing will be discussed at length. And the last thing very important is all your smartphones it is going to be on a dying era. You're going to have what we call intelligent phones. These intelligent phones itself will be so intelligent that they automatically talk. Suppose there is an issue similar to a wearable devices. Some issue with your health, these intelligent devices can talk to the hospitals, get the information, even trigger ambulances on its own. The sky is the limit of the sensors, what is going to happen. So we are moving into a complete intelligent era. Going into the three essence thing which we talked about, the network sensing, the connected intelligence, the application scenarios are different. So now with the AI put into being, so the AI native communication is going to come in. That's a create very essential, the AI native communication. It has its own transmitters, and it will have its own receivers. Now, most importantly, we are moving into what we call a haptic communication. Now, you know that when I was talking about, in the first session, I was mentioning that it's going to become a marriage of man, object, machine, and gene. The most important gene function is nothing but is semantic communication. So it will be, the communication itself takes a different sphere. That is what we are trying to go into the AI native communication side. Network sensing, morning, I think I was already mentioned, you'll be able to sense that you are available without any sensors available in your body. That's how the system works. As you mentioned, the localization takes up to a few centimeters, the calculation, that is possible. And the entire thing is connected on an intelligent platform. So that's what we call connected intelligence. Of course, the intelligence also moves to the edge. We'll come to the next. So that is what we call the edge AI, that is empowering your AI. So the intelligence actually happens at the devices, the edges, and then it goes to the core. So that gives you various rise of applications which we mentioned earlier. Let us see what are the enabling technologies. When you have these enabling technologies, of course, we need to have continuous area of, say, 90 gig. So one area, I think morning, a lot of spectrum discussions happened it. Probably we need to have a terabyte per second, means probably we should even large frequency. Very interesting, network service provider's role. Everything is going to have a sea change in years to come. I just mentioned about the edge AI also. Another very, very important, of course, the earlier sessions, somebody touched upon it, was ambiguous connectivity which is across all, not only for terrestrial. It could be airborne, satellite, or underground. So it will be ambiguous connectivity. That is going to be the key. And to all drive this, a bit of quantum is also required, because when we talk about the security of the area, though we build in a lot of network security, we need to go on quantum cryptography, quantum-enabled machine learning. So quantum computing is going to come in a big way. So these new technologies are all going to be these enabling technologies. To put it in short, what is happening in, I'm very sure all of you are familiar with this triangle, the EMM, MTCs, and the URLCs. Now, these define what are the services, right, from 3D videos to your self-driving cars, to gigabyte in a second. But now what is happening, of course, instead of directly going to a 6G, there's something called a 5.5G. Of course, different people like Huawei come up with this vision. What they try to do is something for the uploading of your HD. So something was introduced, like upload control broadband communication, that UCBC was introduced between EMM and MTC. That was a small triangle which we have brought in. And the other one was on the real-time broadband communication. That was another thing. These two came up. Apart from it, on the user side, a small bit of human interference, that is human-centric services. All the human-centric services came in, that is the HCS. That was the 5.5 if you keep it. The real 6G vision is going to be an extended version of this EMM. So with the cognitive agile EMM, that's what we call it. The real-time broadband, this is going to be extended one. Of course, on the URLC, we are going to go, lot of devices going to add density. So we are talking about extended density URLCC. That's going to be an extension of it with human-centric services. Of course, on the MTC, you're going to see the UCBC and the COC, computer-aided oriented communication. That's another step which is going. This is going to really bring in various services, as we mentioned, federated learning, AI, network, industrial 4.0, etc. The key thing is this triangle will slowly go into what we have a complete sea change on new media, new service, new infrastructure. That's what we talk about. We were talking about security in the morning. For that, the infrastructure, the new infrastructure builds in something called trustable infrastructure. So you build the infrastructure itself as trustable infrastructure with federated network and a complete integrated terrestrial communication, which I mentioned between terrestrial and the satellite and the airborne stuff. More interestingly, they are even planning to bring in drone BTSs, flying BTS. That is what we call flying BTSs, which will be ensured, because you can't have any single point without any coverage available. In a 6G, it should be a complete coverage, carpet coverage. To achieve this, different types of technologies needs to build in. Of course, the new media, it could be wearable glasses, as I mentioned. The smartphone era will slowly die down, and everything is going to be using smart, maybe glasses or shoes or watches or tabs, all intelligent devices connecting together. And on the media side, it will all be virtual. Your education, your painting, tourism, everything becomes virtual with a real new infrastructure coming into place. That brings into what we have the three key important connectivity. That is what we call the sagging networks. As I told you this, when you have this ambiguous connectivity, your surface, air, and ground information network will become a reality. So that's what we call the SAGIN networks. That's becoming a reality in 6G. And everything is going to be intelligent, as you mentioned. It's going to be completely intelligible, very important, controllable. Every device, suppose you have an RIS painted on your wall, these wall devices also could be all controlled using an RIS controller. The RIS controller will trigger which particular device is which antenna. So every antenna of every user to any antenna is easily controlled using an RIS controller. So that is what we are thinking in an RIS assisted system. We are talking about holographic communication. We are talking about deep connectivity. All this is all possible with the advancement in technology, what we think about. So to put it in a nutshell, these are the various dots of the technology that is all evolving. Concepts of everything connected to a network, everything as a service, semantic communication, augmentation of human intelligence. The backscatter communication, which was already there in 5G, itself is now going to be used in a better way for communication. That's another one. Of course, the human-centric wave framework. Most importantly, the quantum also comes into with QC-assisted communication. That's another area of research going on. The spectrum, I have just mentioned, any range of spectrum could be used in any devices. We are not going to be having any spectral sensing. So a new technique for spectrum sensing is coming into being, be it blind detection, eigenvalue, cyclostationary. These are different technological advancement that is happening. We are slowly moving into what we call time convergence. Everything is converged into a common family, what we call the time convergence. We have the quantum artificial neural networks coming in. The sixth sense, when all this comes in, you're going to be intelligent network. It's completely, that's what we call, can we develop what we call a sixth sense communication network? That's another area of research. So it's a complete AI solution with intelligent cognitive self-sustaining networks. We were talking about QoS earlier, quality of service. Then slowly we came about different types of the quality of service variants. Now we are going to talk about quality of life as a parameter for these services. So QoL, that is run on what we call generative adversarial networks. So as you can see, you have new technologies going to come in and really do a thing. As far as the infrastructure is concerned, new infra with infrastructure, with fusion infra, innovation infra, integrating ground, UAV and satellite is going to be the real game changer. And another very interesting thing of the entire stuff is two very important technology: fluid cells and fluid antennas. Let me come back to this. With this, the driving applications drive the trends, and the trends are driving the various enabling technologies. One of the research paper, of course, puts and predicts 6G as this graph. Very, very interesting graph, very lot of data available. I was mentioning about fluid cells. Fluid cells are any BTS automatically depending upon the load capacity could change its altitude, its information. So they are become fluid. That's a new technology. Cells are becoming fluid cells. Fluid antennas, very, very interesting research going on. Any antenna through a type of fluid material like mercury will be able to tune up to a particular spectral wavelength in the transmitter. We talked about the integrated frequency band transmitters, which use fluid antennas. It could be ST fluid antennas. So as we can see on the right-hand side, you can even start from your body area network, sensors, massive information, gateways, completely. On the other side, we have the reflective intelligent surfaces, or even your walls, large intelligent surfaces could also act as a wall. Device to device, fluid cells, vehicle to vehicle, and it will be complete integration. You can see on the left-hand side, from your underground, that is from your submarine to your space shuttle, you'll have all the interconnectivity happening smooth, true broadband speeds. So in short, massive IoT, massive MIMO, tiny cells, cell-free, fluid cells, wave, multi-terahertz, visual light communications, another very new concept is coming for the smart homes. If you can see the figure inside the smart homes, it is all similar to Wi-Fi. We have the VLC in a very big way coming up. Fluid antennas, large intelligent surfaces, vehicle to vehicle, device to device, NOMA, intelligent cacking. Cacking is intelligent. Energy harvesting. As I mentioned, the devices will become intelligent and it can do harvesting. Wireless backhaul and an integration of all these satellites, which will actually drive the entire quantum system. Of course, this is a rosy picture of what is going to happen in the 6G we have projected. Each one of these technologies are having a problem and research is going on. I wish each one on this room to at least go back with one or two of these technologies and see how we can take this forward from the Indian perspective. Let us take the terahertz band communication. We need to have this fabrication testing of antennas, real-time control algorithms, communication protocol coordination is an issue. Intelligent, I was talking to you about the intelligent communication environment, the surfaces. You need to see the trade-off between the dimension and the energy consumption, the compatibility, standardization, how we are going to use it for the existing environment, how we are going to introduce AI-driven. These are some of the open problems. And the AI, the pervasive, we are going to talk about the pervasive AI. Well, what is the generalized algorithms we need to use? What are the effective comparison metrics that we need to bring in? How the network should be automated? What should be the accurate intent that is required? We talked about reconfigurable transceivers. Of course, it's a very novel design, but this design will have all spectrum communication. How do you do this reprogrammable circuitry? How the interconnects will happen? What are the type of antenna? They require novel integration and real packaging techniques because you have to pack number of devices in a small 1 square centimeter of area. And the backscatter communication is going to have a real spectral and energy efficient thing which we talk about. And of course, we talked about the Internet of Space things, combining all the ambiguous connectivity, how we are going to design a multi-band transceiver that is going to take care from satellite down to submarine. Low, but it should also be low latency because immediately it should have a reference, low latency, high speed. How are you going to hand over it? And of course, we talked about the cell-free MIMO. Because no longer the honeycomb cells are going to disappear. We're going to go into what we call a cell-free MIMO environment. For that, how are you going to use the user scheduling? How are you going to do the optimization of the APs? Because you know that in any room, I told every antenna is going to be on a user. You're going to have n greater than k. So how particular AP will take a particular antenna, that requires real optimization techniques, Internet of Nano Things, the power efficiency model, bio things, quantum communication. Quantum communication, we talk big, but the very, very key thing is your quantum error correction. The moment the quantum computing happens very, very fast, but the problem of quantum error correction really takes over. For example, to do one calculation, you need to do X amount of computation to have the end quantum error corrected. How are you going to balance it? These are some of the open problems. If these problems are being completely rated, we can have a clear vision, 6G, what I talked about, a reality. I'm sure you should be ignited of these opportunities that are available. Let us take back one of these areas, and I'm sure we should start working on these areas to make 6G a reality. Thank you.